Okay, guys, since we're a little bit having a time constraint, I'm actually gonna skip these next two examples. I looked at your homework and there are none that are in there like that, so it's not really a huge deal. I hate that we are skipping some application problems, but there are none on your final like that either, so it's not really a huge deal in the grand scheme of things. So we are just gonna skip those. So we're going to skip down here to proving a cofunction identity. So using a difference formula to prove the cofunction identity, cosine pi over 2 minus x equals sine x. So we're trying to get from the left side to the right side. So we're going to want to use one of these 6 formulas up here to get to this right side right here. So it's going to be so it's cosine pi over 2 minus x. So cosine a minus b. So it's going to be number 4. Cosine a minus b is cosine a cosine b plus sine a sine b. But instead of a and b, our a is pi over 2 and our b is x. So now that we have our formula and we have our two pieces, all we have to do is plug in to our formula. So we have cosine pi over 2 cosine x plus sine pi over 2 sine x. And remember, we're supposed to be showing that that is equal to sine x. So now we're going to evaluate what we can. Obviously, our cosine x and our sine x we can't evaluate because x is our unknown. But pi over 2 is on our unit circle. Remember, that's our 90-degree angle. You should know the value of pi over 2. Remember, even though we're not in school right now, still look at that unit circle once a day. I'm going to expect you guys to know it when we get back. Cosine of pi over 2 is 0. So that happens really nicely because 0 times cosine x, that just ends up being 0. Plus, sine of pi over 2 is 1. So 1 times sine x is equal to sine x. So that shows us that sine x is equal to sine x. So we just proved that cofunction identity. On the next one, we're going to be using sine x minus pi over 2. So that's going to be sine a minus b. So up here, sine a minus b, that's our number 2. So we're going to be using sine a minus b is, let me switch colors just because. Sine a cosine b minus cosine a sine b. So again, our a is going to be our x and our b is going to be our pi over 2. So we have sine x cosine pi over 2 minus cosine x sine pi over 2. And we're supposed to be showing that that is equal to negative cosine x. And remember, you can always pause me and try this on your own before you watch me do it. This is a try, so in class I would be having you probably try this on your own before we would go through it together. So just like up here, cosine pi over 2 was 0. So cosine again of pi over 2 is 0. So sine x times 0 is 0. Minus cosine x times sine pi over 2 again. Remember sine of pi over 2, which is like sine of our 90-degree angle, is 1. Well, negative cosine times 1 is negative cosine. So that shows us that negative cosine x is equal to negative cosine x. So that shows us that we just proved that cofunction identity. So this is a lot like when we were using in section, what was it, 7.1 and 7.2, when we were proving identities using the Pythagorean identities and all that. That was a lot like doing that, except now we were using our sum and difference identities. All right, so now we are simplifying each expression. Oops, sorry. Oh no. Okay, what is this happening? So cosine theta minus 3 pi over 2. That's definitely cosine a minus b, which by now cosine a minus b is cosine a cosine b plus sine a sine b. I have it memorized. If you don't, just flip back up to your identities right here, and it was number 4. So now instead of proving a cofunction identity, we're just simplifying. So like section 7.1 and 7.2, this is kind of where you guys were simplifying instead of verifying. So your A is your theta and your B is your 3 pi over 2. So we have cosine theta cosine 3 pi over 2 plus sine theta sine 3 pi over 2. So cosine 3 pi over 2, that's our 270-degree angle. So remember, that would be this one right here. Cosine of that angle is 0. So we have cosine theta times 0 plus sine theta times, well, sine of that angle is negative 1. So 0 plus negative sine theta would be negative sine theta. Now we've got a tangent one. Remember, if I'm going too fast, you can actually pause me. I know I'm sounding like a broken record here, but... So now we've got a tangent one. This is tangent A plus B. So if we look up, this is our first tangent one. Tangent A plus B is number 5. We've got tangent A plus tangent B over 1 minus tangent A tangent B. And the book actually starts us off with a not so easy one, but that's okay. So we've got tangent A plus tangent B over 1 minus tangent A tangent B. Now, pretty straightforward. Again, our A is our theta, so that's really straightforward. We're just going to plug in our theta for A. But our B, if we think about our unit circle, is 3 pi on our unit circle? And your answer should be no. 3 pi is not on our unit circle. But if we think about it, pi is right here. And if we just go around a whole revolution, oh no, what did I do? Oh, here I am. Sorry guys, I keep hitting random buttons. Probably making you guys dizzy. If I just go around a whole revolution, 2 pi, well, pi plus 2 pi would give me 3 pi, and I would end up right back here at pi. So 3 pi is the same as pi. So you can plug in pi for 3 pi, you can plug in 3 pi, and just imagine that, hey, it's just going to be pi. Doesn't matter, okay? Just know that when you plug in 3 pi, you're going to actually be evaluating for a tangent of pi, okay? So let's just do it. Tangent theta plus tangent 3 pi over 1 minus tangent theta tangent 3 pi. Okay. Tangent theta we can't do anything with. Think about tangent 3 pi. Tangent is sine over cosine. I'm going to do this over to the side here. Tangent is sine over cosine. And we know 3 pi is the same as pi. Sine pi is 0. Cosine pi is 1. So 0 over 1 is 0. So all my tangent of 3 pi's are going to be equal to 0. So this is going to be 0 and this is going to be 0. So I've got tangent theta plus 0 over 1 minus tangent theta times 0. So what I've really got here is tangent theta over 1 minus 0, which is tangent theta. So again, kind of crazy that that whole thing kind of simplified down to tangent theta. So what I'm going to do is I have a couple really, really similar ones that I'm going to post on the classwork on Google Classroom, and I'll send you an email too when I upload this video, and I'll put a part in about that, so that you guys can try it, and just so that I can take a grade and get some buffer grades in for it too. And yeah, so I can try to help you guys out. I am going to end it there just so this video isn't too hard to upload. I really miss you guys, and I hope that these videos are helpful. Please, if you have any questions, comment on the post, email me, text me, whatever. I hope you guys are doing all right, and I'll get another one uploaded pretty soon. So, see ya.